For our last unit, we're going to talk about rotating regions around the x-axis or horizontal axis and vertical axis. So we're going to review the discs and washers, which is just the last thing that we did last month for chapter 8. Okay, so first of all, when you're finding area, so let's talk about area straight. You're going to subtract the upper minus the lower, or if you're doing area in terms of y, you'll subtract the right minus the left. So I'm just going to quick jot down area here. Our area would go from bounds of a to b, and the upper function is f of x, and the lower function is g of x, and then dx. But if you're finding area in terms of y, then your bounds will be c to d, and you're going to start with the g of y function instead, and then f of y dy. So you're going from think right, upper to lower, and right to left. All right, if we are rotating to create volume now, rotating around an axis of revolution, we're going to call that axis alpha. And it looks like I forgot the volume using, I didn't put on volume using discs. So we do need to have discs first, and then we'll talk about washers. So where can we put that? Let's add volume using discs right here. Okay, if we're going to use discs and we're rotating it around, we're going to have a to b, and then we're going to be using pi and the radius squared. So we start with the upper radius, which would be f of x, minus the axis of revolution, and then minus the second pi, and then the lower minus the axis of revolution also. And that whole thing is grouped together with dx. And you could also pull the pi out to the front if you wanted to not have two pi's distributed, but you could pull your pi out to the front. All right, we would use a volume of washers if we were rotating around an axis of revolution that was horizontal. You'd have to convert everything to y. I don't know if you really want to do that. I don't like that as much. All right, let's go over to the y terms. This is more often when you're going to rotate around this axis of revolution. You're going to want to use the shell method, I think, when we do this one, because then you don't have to switch to y, you can stay in x. If you stay in if you stay in discs, okay, let's do the discs here. So you'll have c to d, and then I'll put pi in front this time, and we go from right to left. So g from y minus alpha, quantity squared, and then f of y minus alpha, quantity squared, that whole thing, big parentheses, dy. But I would suggest, if you're going to do a vertical axis, I think shells is the best way to go here. And so I would recommend doing shells, because then you get to stay in x, which is always a better option, in my opinion. So if we're staying in x, we'll have back to the bounds of a to b, and then we'll have 2 pi, and then we've got x minus alpha. Okay, that's your radius, and that should be in absolute value. And then we have the height of our shells, which would be f of x as the top minus g of x on the bottom. So this follows the pattern of 2 pi r h. So 2 times pi times r times h, and allows you to stay in x when you're integrating. So I prefer that method if I'm working around an axis that is vertical. All right, so let's try a couple of these. Let's find that we're given the region R, and we're given a cubic, and we're given a square root. Okay, these are going to have some irrational intersection points. So you'll need to find those two intersection points on your calculator and store them, remember, as stored values. So that's your first AP tip, is to store values in your calculator for accuracy. Don't ever round anything. Always store the full and complete irrational number. And then label them on your graph. So this is 0.28364 and stored in your calculator. And then this B is 2.9409. So having those values stored will be really helpful. All right, so to find the area, always write down your integral first. Never just write the answer. So that's your next AP tip, is always write a clear integral. And I noticed on your last one that I docked some points for is that you have to remember the d portion, the differential portion. Okay, so including the dx, that's part of the integral. So we're going to go from a to b. You just have to write a to b. If you've written, assuming you've written the a and the b values somewhere else, then in your integral you can use the letters a and b. So we're going to subtract, and we have the square root, which is the upper function. Whoops. Square root of x plus 3, and then we're going to subtract the lower function, x cubed plus 3x squared minus x minus 4. And then you are totally allowed to use Math 9 to evaluate the rest of that. And in fact, you can even simplify it by just writing g of x minus f of x. If g and f are given in the problem, you don't have to waste your time copying those down. Go ahead and just write g of x minus f of x, as long as they're identified somewhere. And that came out to be 6.295. Remember, 3 decimals. Okay? All right, now we're going to rotate this around the horizontal line y equals 1. So the horizontal line comes through here, which is below the region. And because it's a horizontal line, we'll be using, I would recommend the discs method, discs washers method. So my volume is going to be a to b, and I'm going to put my pi out in front. So then again, I can write g of x minus 1 quantity squared minus f of x minus 1 quantity squared, the whole thing dx. So I do not have to write all of the parts of the function. I can use f and g. And then you'll use your Math 9, and that is 123.865. Now suppose that the axis of rotation was 7. Yeah, okay, so that was up here above the region. All right, well, what changes about that? Well, first of all, what would have to change would be the subtraction, of course. So then we would have minus 7 instead. But what also has to change is the order of the functions, because the f of x function is now farther away. The cubic function is farther away from the axis of rotation. So if you don't change that, you would end up having a negative number, which should be an alarm signal to you that something was wrong in the inversion of your order on your original integral. So final AP tip, just to remember, the furthest function from whatever axis you're using comes first. So whether that's the farthest right function, if the axis of revolution is on the left side, If the axis of revolution is on the right side, then it'll be the farthest left function. If your horizontal axes are below, then your furthest function would be the one that's above. And if your horizontal axis of revolution is above, then the furthest function would be below. So that would be your other AP tip. All right, so we're done. We're done with reviewing everything from here on out. It's just going to be practice, practice, practice. And I know you might feel a little defeated and your confidence a little bit down right now, but don't worry, I have faith in you, and you just need to believe in yourself, and we'll get there together. All right? Have a good weekend, and I'll see you guys next week.